Hello and welcome to this episode of Conscious Design. I'm your host, Ian Peterman, and author of the Conscious Design book. And today I'm excited to have Ravi Toor. He is the founder and managing director of Filamentive, making 3D printing more eco-friendly. Welcome to the show.
Thank you, Ian. Pleasure to be here.
Awesome. So, origin story. Everybody loves to hear where you started. What got you to start Filamentive and dive into 3D printing from an eco standpoint?
For sure. Yes, very good question. Filamentive as a business, as an idea, has been in existence for like 8 or 9 years now. But it was really around 2013 when I really got an insight into 3D printing. It was in the media a lot more. The patents expired, so printers were getting cheaper, more low cost, more accessible. So I started to hear about it a lot more. And, as someone interested in technology, I did gain more awareness. And at the same time, I just began my undergrad degree, my bachelor's degree at the University of Leeds, which was in the environment. So environment and business was the title of the degree. And I was currently learning about sustainability, becoming a lot more aware of our impact on the planet, different types of materials. And so I was thinking, well, 3D printers, they use plastic. A lot of the plastic at the time, especially 2013, around the early days, a lot of it was fossil fuels-based, petroleum-based plastics, ABS, rather than bioplastics, which we'll get into. A lot of the manufacturing was done in the Far East, which, economics makes sense, but a lot of transportation mileage, a lot of carbon impact. So, didn't have all the, small details of how I was going to put this business together. But it was around, 2013, 2014, I thought, well, we have to do this more sustainably. There needs to be a better way of producing materials for 3D printing, whether that's recycled materials or biomaterials. And, I wanted to be that change in the industry.
I'm glad you mentioned it because there's a lot more material options now than there were before the first options. And you mentioned bioplastics, and people love that, right? It's always good, but it's taken a while to get here. Now, for you guys work in the filament space. What are you mentioned, recycled materials, biodegradable. What are those areas that you guys are able to go, hey, these are better options than just virgin petroleum-based plastics? What can we have now? What's our options?
For sure. As you quite rightly said, Ian, things have moved on in the industry overall for better, for certainly more sustainable materials are out there generally. In terms of Filamentive, in terms of what I think we offer, and I'd like to think we're sort of benefiting the environment in terms of prioritizing recycled material. I came across a fact in a Medium article, so, nothing too widely publicized, but there was an interview with somebody in the industry, and he said 99% of the filament we use in 3D printing is non-recycled. And, that stood out to me as 3D printing is additive. We're not subtracting material. We're building layer by layer. It's less wasteful. But if the industry is growing, there's more 3D printing in prototyping, in manufacturing. If 99% of it, or even, call it 90, whatever the number is, the majority is coming from virgin plastic. I was listening to another episode of this, I believe, with the founder of SUS. And, you made the point of extending resources. And I think that's how we need to think of plastic. Let's not say plastic is the problem, more so thinking, linear, take, make, waste. So a lot of what we do, Ian, is taking existing plastic, mostly post-industrial, pre-consumer materials. So plastic that has been sort of rejected from a production process that would otherwise go to landfill. We take that and use it as input material as filament. So granted, it hasn't been a post-consumer, an actual physical product in terms of post-use, but we do prioritize post-industrial recycled materials as a way of making use of what we already have. This plastic's been made already. It would go to landfill, possibly worse if we don't reuse it. So Filamentive commit to high percentage recycled content in our 3D printing materials.
Got it. So you work with like manufacturers and kind of that end of the supply chain primarily for the recycled. Because sometimes you'll do 3D prints, right? I run a design firm and we'll do prototyping and not all the prints come out right. You'll like get a bad print or you'll get, you'll have the prototype, you'll look at it and go, not good, go redesign it, right? Because it is one of those very easy, right? It's easy to go make a change and then 3D print it, make a change, producing a lot more. Is it something that you can recycle after 3D printing? Can that also be post-manufacturing pre-consumer waste, or is it more other like injection molding and things like that?
More so the latter, Ian. So we work with injection molding firms, even filament manufacturing firms, people that produce sort of extrusion products, whether that's filament or other types of plastic. There is, a failure rate in them processes. And, sometimes the color's off or it was out of spec, that kind of thing. It means that we can almost guarantee virgin properties, but in a recycled grade of material. However, you do make an interesting point on the failed prints or like unwanted prototypes. It's a big question, probably the number one question we get via phone, email, live chat, or, whatever contact we get from customers. It is the number one thing. And I think it is a big issue in 3D printing. We do our own research on this with our own customers, but, I think the latest number we had was 33% of all prints become waste. Most of that being failed prints, support structures, if you're doing complex geometries, which 3D printers allow you to do now. And like you said,
Yeah,
it's very easy.
which is great.
Yeah, for sure. It's so easy that we are producing quite a lot, whether it's a prototype or a final part. We don't take that waste back directly and as input material for the filament. I think there's a lot of quality control concerns, contamination risks, reverse logistics, a lot of the economic and sort of logistic barriers. That being said, we do offer an open loop solution, as I like to call it. So we've partnered with another UK recycling company called 3D Printing Waste. As the name suggests, they are involved in the niche of 3D printing plastics only. They sell recycling boxes in two sizes, and 3D print operator can put all their waste prints in there, failed prints, support material, real ends from filament that maybe there wasn't enough to do a print with. Once that's received back by 3D printing waste, it's kind of all melted down, processed, pelletized, and it goes to secondary markets. So other recycling companies that take it back as like a bulk stock of recycled material. And that's then, I believe, it could go anywhere because it's sold as almost like a recycled resin, but it can be fed back into injection molding or other kind of upcycling methods. So whilst it isn't closed loop, goes back into filament manufacturing. Don't get me wrong, that is my goal and an ideal solution. We do advise going through our partners 3D printing waste, and we do absorb that as a cost as a business. So as long as customers reach a certain spend with us to cover that cost of recycling, we just send them out a free recycling box, and it will mean they can recycle all their waste or as much of it as possible.
Amazing. Now, and you mentioned kind of the pelletizing and things like that. You guys are focused. Well, I know there's like laser sintering, right? There's different kinds of 3D printings. You focus just on the reels, the filament, or have you gotten into other kinds of 3D printing? How broad do you work, and what kind of feedstock recycling material can you take in?
So we work primarily in the filament-based extrusion, Ian. So the fused filament fabrication, triple F 3D printing, probably what most people associate with 3D printing. So using the plastic filament and it melts and builds a object layer by layer. But of course, 3D printing is a catch-all term now, isn't it, for a lot of additive manufacturing. So, we don't work with SLA, which is resin-based. We don't work with sintering, which is typically metals, powders, that kind of thing. We want to, and I think, that's maybe further down on the roadmap of kind of offering sustainable materials for some of those processes. For now, we are primarily filament focused. So all of the plastic-based printing, which, granted, primarily is with bioplastic material. PLA, as you may be aware, Ian, and some of our listeners that have a 3D printer, PLA is a bioplastic. It derives from cornstarch, sugarcane, much lower environmental impact because it's not petroleum-based. That being said, there is a lot of misleading marketing, greenwashing, as some like to call it, and say, PLA is a bioplastic. It will simply, biodegrade in a couple of years if you leave it in your garden. Unfortunately, that's not the case because the research, the academic literature suggests you need industrial composting facilities, so actual sort of huge kind of facilities that,
Are you going to make it happen?
that makes it happen. You can't just leave it in the soil. You can't, leave it in landfill. Most PLAs are not certified compostable in that way. So we do face that a lot because people say to us, "Oh, we don't need to recycle it. We'll just, put it in, this waste bin or wherever." So there is a big education thing, which with sustainability there is generally to overcome
Yeah.
sort of consumer perceptions. That's half the battle, right? Education and communication. So PLA is the number one material in 3D printing, granted. So it is better than using maybe an ABS or some of the other petroleum-based plastics that were used 10 years ago in the early days. But we still need to make sure there is responsible end of life to it. And the education needs to be there to say, well, what does an operator need to do? What does a school, a university, a manufacturer, a product design agency, what information can we give them as best practice to deal with 3D printing waste and that kind of thing?
You don't have any issues recycling PLA then. You're able to take that in, correct? And make new filaments you can use again.
So technically, yes, we've done our own experiments, but we have seen degradations in some of the properties after you recycle PLA or any plastic, X amount of times. Typically between 3 and 5 extrusion cycles, you tend to see deterioration in sort of tensile strength, these kind of things. So we're not actually recycling the PLA waste into filament again. We kind of, advise other kind of landfill diversion strategies for that. With the PLA we take in from manufacturing processes, it's only gone through one cycle. So, it's been extruded or injection molded in the factory or the production facility. And, it's been rejected and sort of repelletized and extruded again into the filament that we sell. So it's only ever gone through one extrusion cycle. Technically, when our customers use it for prototyping or production, there is another melt cycle because of how a 3D printer works. But we haven't seen any noticeable difference in properties to the point where a consumer would say, well, it might be recycled, but it's lower quality. And we get that because I think people want to be sustainable, but they don't want to compromise on strength and these kind of things.
Right. It needs to do what it's supposed to do. That's if it doesn't, it defeats the point of using the material at all.
100%.
So that's great. But you're saying that you can do it once. A once recycle, you're able to double the lifespan almost of that material.
For sure.
It's not as, because there are some plastics that are more recyclable than that you can use quite a few times. And nothing beats aluminum, really. But as far as plastics go, there are some that can, but PLA isn't let's keep using it again and again and again type of material. Are there any that you are able to really recycle a lot in terms of creating filament, using it, recycle it, or does it not last that long for 3D printing? Is that?
I think for 3D printing, it doesn't last that long. Something like an ABS or a PETG might offer more extrusion cycles that you recycle it a bit more. I mean, PETG is what our drinks bottles are made from, all the plastics, plastic water bottles, that kind of thing. There is quite a strong, recycling history and kind of infrastructure for recycling some of these plastics. But as far as 3D printing goes, yeah, there is limitations, which is why, yeah, we can only kind of double the life of certain plastics with our kind of production model. But, I think it is that approach of, improvement, not perfection, because whilst there are other filament brands that are following our approach and, we're not the only ones doing it, the vast majority are selling virgin plastics. And with the whole, 3D print waste management issue, the quality control concerns, the reverse logistics, that plastic isn't being recycled. So, we do our bit and that research is ongoing and we are looking at ways of extending that life cycle. We are hoping one day we have a closed loop system where we say, look, send all your waste back, we'll recycle it, we then resell it and kind of have that as a second life filament. And there's lots of different things you can do. And, I do defer to some of our technical specialists and the kind of polymer chemists on this, but you can add in virgin material, not too much to mitigate the environmental benefit, but, let's say you add in 20% virgin plastic into a compounding, you kind of overcome that risk. You're de-risking that quality control concern. And you can still say it's 80% recycled, 90% recycled. So there is sort of ongoing research that we're looking into, as well as, some of our partners. So whilst we maybe don't always get to 100% for good reason, how much can we extend life cycles? It's a constant thing of continuous improvement, really.
Hey, it's Ian here. So glad you're enjoying this episode of Conscious Design. If you want the full scoop on conscious design, what it is, how we do it, how you can do it, then check out our book. We wrote it so creative entrepreneurs like you can code social and environmental responsibility right into your brand's DNA. You can download the first chapter for free. Link is in the description. Enjoy the rest of the episode. Don't forget to like, subscribe, and share.
So for you guys, talk about some of the issues that you're running into in creating a closed loop, because it sounds like that's the goal, right? I think it's the goal is to eventually get there in terms of, okay, material goes out, material comes, all the waste comes back, we're able to loop it in. You mentioned a few things on that, but I'd love you to dive into, because you're working towards that. What are the biggest hurdles? Like, what is, as of right now, what are the biggest blockers that makes it just not financially feasible? Or is it money? Is it technology? What are those blockers keeping you from being able to create a more circular loop with these materials?
Very good question. And again, something we get asked a lot, and we try to be transparent on as well, and say, look, we can't offer this now, but here's why, here's what we're working towards. I think the first thing is that risk of contamination. So it's almost that pre-recycling or pre-cycling, as some people call it. So let's say a company or a business uses multiple types of plastics. If there isn't proper segregation, the end user side of things, you could end up with a massive PLA, PETG, ABS, especially if it's all the same color, because every printed part within reason looks, the same. So it's almost that kind of, we can give the education and you can almost 99% verify it. If you say, ABC Limited is only using PLA, you can't necessarily, trust sounds a bit antagonizing, but you can't always be sure that the human error doesn't come into play. So ABS goes into the PLA bin, vice versa. The reason why that is an issue is because the technology isn't there to scan the plastic and identify smaller pieces or certain pieces, because I think it exists on a broader scale at like council and government level facilities where they can say, yeah, that's aluminum, that's plastic, and that's sort of different types of plastic. We've looked at more accessible, more affordable solutions, and you cannot differentiate the different types of plastic. It either doesn't pick it up or it can't necessarily pick out what plastic that is. So there's a big contamination risk, which you can put into sort of the human error or the kind of behavioral element to it. But I think the technology is limited to allow us to identify and separate as well. So we can be sure that everything coming in is 100% of X material. Now, when we've thought about this, and maybe it involves a wider industry collaboration, but is there material standardization? Is that one measure we could take? That's a question I ask myself, and we do as a team, as a small team that we are. But, should we advocate for PLA only? Should we, come up with something else? Can we standardize to avoid that problem? In theory, yes. But I think because of how 3D printing is now so accessible and so versatile, there is different applications that require different materials. So, PLA, great for prototyping, low cost, easy to use, for product development, these kind of things. It might not be a good end use part in sort of a car engine bay where the temperatures are so high, right? So, for that, you do an ABS or a polycarbonate. So, 3D printing lends itself to kind of the material range that is out there. And I think we touched on that in the earlier part of the call. So it's a catch-22. It's like the material science has come so far that we have 20, 30 materials. But I think that is inhibiting us thinking circular in terms of standardizing those materials. And that isn't me, shying away from what we can do. I just think, that there's more we can do as filament sellers and filament manufacturers in general to kind of standardize materials. Aside from that, Ian, let's imagine we did overcome that and we standardize. I think there is the whole issue in plastics recycling generally of having the volume to weight ratio, right? So, plastic is quite a lightweight material. Transporting it is quite expensive, especially if depending on how the 3D print is. Who bears that cost? Does the consumer, the end user, need to package up that plastic, send it to us for 10, 20 pounds, dollars, whatever it is? There is a cost associated. That kind of falls into extended producer responsibility and that kind of thing. Do we add a cost onto our filament products to cover recycling? It's a possibility. We're very early stage exploring, doing that kind of thing. So, yeah, it's a combination of the contamination risk, the technology for plastic scanning and identifying different types of plastic, and then the cost and operational challenge of like reverse logistics, I would say, getting that plastic back to us cost effectively and, the most efficiently way possible.
I feel like across the board, every industry and company, when they want to get circularity going, reverse logistics some is always on that list. I feel like
Always.
It's always there. We've spent forever figuring out how to send things to someone in a way, like get it to the customer, and the loop back, we've spent almost zero time thinking about or building an infrastructure for. Yeah, it's not there. So who knows? Maybe there'll be a company that all they do is reverse logistics and they figure it out for us. That would be great. That would be.
I hope so. I hope so. I think, like you say, it's not a 3D printing specific problem at all. It's the reason why plastic recycling rates are so low, right? It's, whatever you look at, it's around 5-10% globally. So you can kind of understand why when you do look at the logistics issue, which is why, maybe going on a separate point is, do we need to look at the material? Do we need to look at truly biodegradable materials that can be composted in an end user environment, in compost, sort of home compost, soil, or landfill? Like, does the material science need to develop to where we say, well, we don't need to recycle anymore, which I know is a idealistic, utopia for 3D printing.
Hey.
But, when we think of sustainable materials, it's not just recycled, right? It is those biomaterials that are, biocompatible, but also truly biodegradable in the right environments.
Are there any, PLA is a great example. I love that you brought up kind of the misconception around it due to active and just laziness in explaining how it works, right? It isn't actually throw it in the dirt, biodegrade. Are you seeing any materials for 3D printing? Because I was starting to see more and more for different kinds of production where there are some true what you think of as compostable, throw it in the dirt, disappears in a while, not hundreds of years, like months, right? Is that something that are you seeing anybody bringing it? Are you seeing any trend in 3D printing towards that? Are you working with any companies that are developing that? Or is that still kind of this off pie in the sky kind of idea?
I think it's probably, and hopefully, closer to reality than being that pie in the sky idea, Ian, because we are speaking to some of the bioplastic players and the players in the materials market to see what we can do, because there are certified, whether ASTM or ISO, whatever standard, there are certified bioplastics that do biodegrade within 6 months. 180 days is, I think, the standard, rather than the tens of years, hundreds of years that probably is the case with PLA. There is a high cost to such materials, I'll be honest. That is a barrier to using it in filament form. At the time of discussing this, it's probably 2 to 3 times the cost of a PLA. So that would have to reflect on our selling price, and it would have to reflect on the margins of some of our customers. Not all of our customers do prototyping. We sell to a lot of business owners that create consumer products using 3D printing. So homeware, gifts, these kind of products where maybe some of their customers are increasingly eco-conscious and willing to pay a premium. But as it stands, I think the cost is prohibitive, but it's chicken and egg. With more adopters, with more companies like us in 3D printing, in other verticals, economies of scale, right? We can only bring down the cost of, truly biodegradable materials. And I think specifically to answer, I think the first part of that question, PHA, so Papa Hotel Alpha, PHA is one of those alternatives that is looking promising. Don't quote me on the actual chemical name for that. That it escapes me. Probably have to defer again to a chemist.
Everybody can Google that.
Yeah, we can Google it and bring it up. But it's I believe, as far as I know, it's kind of microorganism based rather than sort of starch or sort of PLA type derivative. But there is evidence of it biodegrading and then being compostable within a certain time frame. So it's very promising. That does exist already. I believe it is used in other markets, in other types of applications. There are some other filament providers selling PHA. A quick Google of that will bring up certain results, but you will see the cost of that. So it isn't something that we at Filamentive have implemented as of yet, but actively exploring. I personally believe, through my own thinking and my experience in the business, but speaking to some of our big customers, speaking to the market and putting polls on LinkedIn and surveys and everything we do to research and get other people's opinion, because you don't just want to be in this echo chamber of thinking, oh yeah, that's a good idea. You need to share best practice, and yeah, it's easily done, isn't it?
Never works.
Never works. It's, we believe all our ideas are good ones, but we have to speak to the product designers, the architects, the universities, and understand what their priority is. Is it recycling your waste, or would you prefer a truly biodegradable material that you could just put in the soil or the composter that's on site at the university, right? Like, these things exist. There are accessible ways of composting. So let's give you the material that can do that. Easier said than done. And, I don't want to make it sound easier than it is, because there is economics. There is education again, because what are people going to say? They've had 10 years of PLA. What's PHA? I'm very risk averse to this. I'm very resistant to it, and understandably so. And I think our role in that will be to overcome the misconceptions, like you say, and sell it on the benefits. Don't talk about maybe the nerdy technical stuff that maybe some people want to hear. They want to hear this will truly biodegrade without you needing to recycle it or worry about sending it back to us. And I think that is the point that we want to get to in 3D printing, and that's the role that we want to have as Filamentive in the next step in sustainable materials.
Yeah, I've heard of that material, PHA, and always seems cool when they first go, hey, physicists or chemists just discovered new material that they blow it all up. Like it's all, and
yeah.
And then like 80% of the time they go, oh, well, on further study, it actually doesn't do.
Yeah.
So it's good to hear that that's continued. And it seems like it's not one of those exciting, but doesn't actually work options, that it might actually be a real option that you can be able to use. That's good to hear, especially from someone in the industry. But yeah, I think it's important. Your approach is good. You guys are really, it sounds like, doing a lot of the lab work, doing the research on the back end to make sure when you actually go sell the material, you can know that it's going to actually do what it's supposed to. It's going to have material qualities, because those are all, it's great if you're a hobbyist. You can be like, oh, it's a 3D printed thing. And, no one's going to get angry at you if it doesn't work properly. And then there's everybody else, like in my world, where it's, oh, I built a prototype and I handed it to a client who just paid for it. They're going to expect it to do exactly what it's supposed to do, right? If you hand them metal, they expect it to be like metal, not crumble in their hands. I think it's really important to do that as you're going, hey, it's more sustainable, and you're not going to lose the quality portion of it. I feel like there's been a lot of giving up quality, and that's kind of how we have where we're at, where it's people are suspicious now in some ways of recycled material. And to your point earlier of like education, I think education is so important. Going, yes, this is biodegradable, but not in your backyard. This material is recycled, but it's not the same quality, but this one is. And really just because I guess we're really good as a species. We're constantly making new things and going, hey, but it's helping to understand, yeah, it's a new thing in this area. It's 3D printing, but now it doesn't mean filament anymore. It means so many other things to it. So yeah, I think it's a big task. So good on you for going, hey, I want to jump into this area and really focus on improving sustainability in a smart way.
Definitely, yeah. It's quite the battle, as you say, Ian, and it's not always easy. And you don't want to greenwash yourself, right? Because one of the things with a PHA or whatever comes next for Filamentive is then having the ability to reassure that end user, and someone saying, "Oh, Ravi, so you're 100% guaranteeing this is going to break down in 180 days, because I've just printed this, and it's this shape and this size, and there's millions of possibilities with 3D prints, isn't there, with size and infills."
And I'm burying it in my garden tomorrow, so I'll call you in 6 months.
Yeah, exactly. And it's like, a very extreme example, granted, but it's being able to reassure the end user and give them the right information to make that decision and being able to do that. But like you say, it's balancing everything, because they want it to last and not decompose in the sun. They might need it to have a bit of strength because, whatever, it needs to have that bit of mechanical resistance. So it's a balance. And that's where we are as a filament business, because we sell a wide range of materials, some more sustainable than others, because of the needs of the market, for the temperature resistance, for mechanical properties. We supply a lot of like public projects where they're putting a sculpture or an arts installation. It needs to last for a certain amount of times. You might have a little kid that's going to crash into it, and it's like, but they really want sustainable materials. That's why they came to us. So it's kind of saying, well, that will work in this context, but be mindful of this. End of life, yes, PLA, biodegradable, but just make sure you have access to the right facility, as you made as well, Ian. So yeah, it's managing expectation, education as well, I think, is the paramount thing, as you said as well.
Yeah, well, and what else comes to mind is it's steps, right? You like it, perfect world, everything instantly becomes sustainable, and I will get there. But also it's being okay with, like you said, well, some of these are more sustainable than others, but if you need, like, your application, you need this. Yeah, of course, if we have a more sustainable option, we'll swap it out for you later. But right now, this is the material that can do what you need it to do right now. And I think being okay with, okay, well, we'll do that, and we'll use a more sustainable material wherever we can. Mixing materials, which makes it bad for recycling, but in some ways it can be beneficial to be able to go, oh, well, this product is this, and this product is, more sustainable.
For sure. And it's how we measure sustainability, isn't it, Ian? That comes up a lot for us all.
Oh, that's a big question. That's the whole, who measures it and how do we measure it?
Yeah, exactly. Is it recycled content? Is it recyclability, carbon impact? So many questions. I suppose it is on us to, build eco profiles and have those metrics. And again, it's just about communication, isn't it? And transparency. But as you say, it's a never ending thing. And like you say, we'll get there, I think, the right approaches.
Yeah, the whole metric thing, I think, is an interesting topic. I think there's many ways to measure it, like you were just saying. And I think my personal feeling is, like, as much as I want to use more metrics than just carbon was a great starter piece. And I feel like now that we're getting to understand that more, we'll add on another metric and be able to eventually, really have this full view of how do we measure actual environmental impact. And I think it's just that, okay, we start with carbon. I don't know what the next one will be, but we'll pick something else and go, okay, here's the second one.
Yeah.
There'll be a new one. And then we won't forget the last one. We're like, oh, we still have to have this carbon and you have to have this. But then I think that also shows real understanding of, if you can understand that about a material and a process, then you can have, control. If you can measure it, you can understand it, you can make decisions about it. Yeah, I'm curious to see what the next one come up with is. But for now, carbon is good. We'll use that for a lot of things.
For sure, yeah. It's very much the same approach from us as well. Carbon and net zero is a global thing now, generally speaking. I think that's what, not to be cliche about it, but top down, that's what a government, tends to speak about. That's what organizations want to speak about. And then, the end use client kind of ties themselves to how do they reduce their emissions, right? And it's on us to communicate, well, using a recycled material is a 50% saving, a 70% saving, and it is a guideline, not an exact thing all the time. But yeah, we'll stick with carbon, Ian. I agree.
Awesome. Before we wrap up, I just want to make sure kind of two things. One, make sure you have an opportunity to share anything that we might have skipped over or missed or you want to say. And then also for everyone watching and listening, what's the best way to find you guys, reach out, tell you about cool, interesting new materials, buy your materials?
Thanks, Ian. I think we've covered off a wide range of things, actually. I think we've had a very comprehensive conversation on 3D print materials to, biodegradability and the misleading of certain other materials and maybe the future. We've had a glimpse into what I believe and what the market believes is the next step in sustainable materials. But yeah, no, it's been a pleasure talking to you. In terms of next steps, or if anybody, is open to finding out more from us, filamentive.com, filamentive.com. You'll learn more about products and how to buy the products if you are 3D printing, but also more information on sustainability, how we manufacture our, recycled content declaration, all the sustainability documents that we hope to be transparent on. We do publish on our website. I'm also quite active on LinkedIn, as a lot of us are these days. So I tend to not just promote about our products from the commercial side of things, but I do try speak about sustainability issues in 3D printing. So you can catch me at Ravi Toor, so RAVI, surname Toor, TOOR. Feel free to add me. Always a pleasure to connect with, like-minded people, not just in 3D printing, but that are truly passionate about sustainability and how we make our planet a better place, really. So yeah, the website for Filamentive stuff and LinkedIn for me personally on sustainability conversation for sure.
Fantastic. Well, this has been amazing. I've really enjoyed this conversation. And for everyone listening and watching, we will have links and everything in the description. So take a look at that. And again, this has been great. And thanks for being on the show, Ravi.
Thanks, Ian. Pleasure speaking to you. Thank you.
And that wraps up another episode of the Conscious Design Podcast. If today's episode inspired you to bring your product idea to life and turn it into a sustainable 7-figure business, visit petermanfirm.com or click the link below. Your ideas have the power to change the world, and we're here to help make that happen. Thank you for joining us, and I'll see you on the next episode.